Hey guys, I've had a change of heart. You're gonna get out of doing one of the gizmos we were gonna do here with Hubble's law, looking at time-wise and third hour. I know you take your exam Wednesday of next week. I think we'll be time crunched because I really want to get into stages of stars because that's kind of where the cooler stuff lies. Hubble's law is all mathematical, so if any of you fellow math geeks wants to do it, I already made copies, so I've already wasted trees. So you can get that from Mrs. Klein. I doubt if there will be any takers. So an alternative, you still need to understand that there is math behind this, and it does support the Big Bang Theory, so I don't just want to say, never mind, all right? So there's like a 4-minute video clip, and it's going to fly, but this is my deal instead of doing the gizmo. So anything that you could be assessed on will come off of this sheet, all right? So write it down. But the video goes super fast, so Miss Klein may want to stop it here and there. But we're going to go through, and they're going to talk about 3 scientists. And the first one is Vesto Slifer. And I'm just going to put his name here. So these are like your look-fors. And then over here, you're going to put what you find out, all right, about him. So he's going to be talking about oranges and reds. There's a hint, okay? Something about that over there. The next major person it's French, and I won't even try to say it correctly, but it's George in our world. Lemaitre, I think, something like that. And for this one, look for the balloon idea. All right, it has to do with space expanding. All right, so that's what you're looking for here. And then down here, Edwin Hubble. This is obviously the person that Hubble's law was named after. And then the very last thing is going to be an open-ended question to some extent. I'm just going to put the universe is expanding with a question mark, all right? So I want you guys as a team here, as a class, to watch this video, talk about it with Mrs. Klein. You're going to pause me at this point, watch the video, and then come on back to me, all right? So pause me. Don't make me go all the way away. Watch the video, and then come back to me. All right, I'm going to assume that you watched the video. So this Vesto dude, Vesto is a cool name, like that. I like that one. But his biggest contribution that got us thinking about this universe expanding is he noticed that the light from stars was changing. Now, you may have something slightly different from that. It doesn't mean it's wrong. All right, I just happen to know what you absolutely have to have here. Okay, so the light from stars was changing. Specifically, they knew that hydrogen should emit light in that orange range. We should get some orange. So, orange spectrum light, I think Roy G. Biv here, from Andromeda, remember the Andromeda galaxy is our next door neighbor, was getting redder by the time it reached Earth. And it's not like it was morphing or changing into something else, but it was getting stretched out. Redshift, we've talked about redshift a lot. It's this person then that actually started to see this, and we started to get this idea of the redshift down. George here, our friend George, what he's figuring out is that galaxies that are farther from us, so galaxies farther from the Milky Way, because let's be honest, we care about us, are actually moving faster away. So the farther the galaxy is from us, the faster it's moving away from us. And we knew that because of this greater redshift. So the farther galaxies, there would have been more of a red shift. And so the question, and what is weird to me, and they do a nice job explaining it, is this balloon idea. So it's almost like space itself is stretching out. Now we think we know that space is just a vacuum. So how do you stretch out nothing? When you show those dots on the balloon, the farther the dots are apart when you blow it up, the farther they are apart when you start, the farther they get. And so what is it possibly out there that is causing this? And Hubble, he just tried to come up with the math. Okay, so he did the math, which is Hubble's constant, to explain or calculate this rate of expansion. So how fast that balloon, I guess we want to call our universal balloon, how fast it was going apart. And his number was just proven wrong again. I feel like it was a few months ago. I listened to some podcast or something nerdy that I do, and they figured out it was wrong again. So they're still trying to fine-tune this, but he got us close. So that was his major constant, his major contribution. So we know the universe is expanding. We know it's accelerating, right? It's going faster and faster and faster. And as the kind of the speaker there said, is it dark energy? What is dark energy? I don't know. All right. I've read some stuff. Is it a fluid? I don't know. I don't know. All right. So there's something. Maybe it's dark energy. Maybe that's bullcrap. I don't know. But there's something that's making us go farther away. All right. So at least wanted you to get this main idea, even though we are not going to actually calculate the constant. We would have done some good, serious number crunching, and I'm sorry, Mrs. Klein, it would have been right up your alley. But in the sake of time, we are not going to do that Hubble's law gizmo. All right,